All right, so number 3 is the last normal problem that we'll do on here. When we need to complete the square, that 34 is in my way. So we're just going to move it to the other side. So subtract 34, and that just kind of gets it out of our way. It can hang out on the other side of the equal sign for a little bit. And then on this side, we're left with, I forgot to write the 10. 10x squared. I'm sorry, x squared plus 10x. I'm struggling. X squared minus 10x. There we go. Plus blank. And we've been working on completing the square quite a bit, but let's go through the steps. So I've got negative 10 here. Divide by 2. I get negative 5. Negative 5 squared is positive 25. So I'm going to do plus 25 here, and then don't forget to do plus 25 over here. Otherwise, half of your answer is going to be wrong in a little bit. Okay, so this is going to be y minus 9, I think. And then on this side, we are going to complete the square and write it in squared form. So what goes in the parentheses?
So x minus 10.
Or minus 5. So let's review that a little bit. So the number that we got over here when we divided is what's going to go in those parentheses. The only reason we bother squaring this is because I have to know how much I'm adding to the other side. Because this is 5 squared, so there's a 25 there, but we had to have 25 over there too. Okay, so now we're going to put this back in y equals form, in a form that I could put into a calculator and graph. So y equals x minus 5 squared, and then plus 9. So this right here is vertex form. So that's usually the first thing you're going to box. That's the first thing that they're asking for. Then I've got to figure out, based on what I know about transformations of functions, how this is moved from the parent graph so that I can figure out where the vertex is now. So how is this translated from the original x squared parent function?
Right 5 up 9.
Good, right 5. And remember, that's just kind of backwards, what's in the parentheses. And then up 9. So my vertex then will be positive 5, positive 9. So the sign here and what you have on that x coordinate are opposites. So in your notes, if you want to put something that says that that's the opposite sign, just to help you remember that, that's fine. The 9 is not opposite signs. It's only that first part. And then my axis of symmetry that divides the parabola in half, for this year, it's always x equals. If you do this with me next year, we'll have some that go sideways. And it's always just whatever you're getting here, x equals 5. So again, that opposite sign of what's in here. So that's the vertical line that divides it up. If you were not sure if this were correct, you could plug this into your calculator. Actually, you could plug the original into your calculator too, and just see where the vertex is, where it's dividing, just double check everything.
Why don't we just rack it to solve it? Are we allowed to do that?
You're allowed to do that to check. We are
Solve it that way though?
Nope. Because completing the square is how we're going to lead up to the quadratic formula. And since I had feedback that you guys don't like just getting random formulas without learning where they come from, we're doing all the things. So we know other algebraic ways to get the vertex and axis of symmetry. But what we're doing is I'm showing you another application of completing the square. And the reason why we're not just going to throw it in the calculator, trying to think where I have it. If I look in my last year's senior math notebook, we do these that are not functions that you cannot graph on the calculator. We make them go sideways. They don't pass the vertical lines test. So let me show you some of that. I'm getting there, almost.
-1.
So, where is it? Oh yeah, I forgot, there was a delay. So you're gonna get to graph some, if you do more math with me next year, that go sideways like this. They're not functions. I can't write it as y equals because it's x equals. And we have to do algebraic things. This is the simpler ones. And then we have more where they're in a version of vertex form. And then when we get to day 3, you get to do this. If you take that class, we're also going to use the completing the square to do hyperbolas, which require you to complete the square for the x's and the y's. And you have to do some other manipulation and also ellipses. I don't want to scare you, I'm just explaining. So when we do some of this stuff, that's not a function. It's not a y equals equation. That's what the equation of an ellipse looks like on the end. I have to complete the square here. I have to complete the square here with a little bonus thing that you're going to see today. And there's no way for the calculator to do it for you. Does that make sense? So I promise I'm not just torturing you. The good thing is that calculator is a great way to check your work. So I am going to look for this particular unit that you can do these steps in preparation in case you are going to take more math. If you don't, then great, you survive this and then you're done. If you do senior math with me, and we get into that pre-calc stuff, that is one of those things. It's got this twice in the same problem. So we're just kind of doing the very tip of the iceberg. Okay, so now we're going to complicate things. I know that makes everybody happy. You cannot complete the square if there's something in front of the x squared besides a 1. So there's a negative there. So what we are going to do with that, I'm trying to think. Okay, actually first we're going to get rid of the 99. So let's do that first. So we're going to add the 99, add the 99. So now I have y plus 99 equals negative x squared plus 20x, if I can write. So this is basically a -1. If I'm going to complete the square, I got to take that off somehow, but I'm not allowed to just completely get rid of it forever. Because what does it mean for that parabola if I put a negative in front? We've talked about that. How does that change the graph?
Doesn't that flips it?
It flips it. So I can't just get rid of this entirely, but what I can do is I can factor it out. So now I'm going to have x squared. If I take 20 divided by -1, I get negative 20x. And my plus blank is going to go inside these parentheses. And right now, over here, the y plus 99 is just hanging out. Okay. So for a minute, we're going to pretend that -1's not there. We kind of shoved it to the side so we can complete the square, because this has to be positive x squared to do it. So we're going to take that -20 divided by 2 like we've been doing, get -10. And then -10 squared is -10 times -10, same signs, positive, so 100. But is it really positive? What would it be if I distributed this -1? Negative. So I'm actually subtracting 100 from this side, so I got to subtract 100 from this side. That step messes a lot of people up. It is kind of complicated to think about. So this is only going to be y minus 1. This -1 is still just kind of shoved to the side. And I'm going to factor this into that nice little perfect square. So x minus 10. And just to review, I'm getting the -10 from that minus 10 when we divided. So even if this were some weird decimal, I wouldn't have to sit and like really think hard about the factoring. We designed this to work that way. Okay, and then I'm going to add 1 and add 1. So my final is going to be y equals negative 1, x minus 10 squared plus 1. So the end result doesn't look that different, but it does have that negative. And we've talked about what that does. That's going to reflect it over the x-axis, okay? So we know that our parabola opens down. And then we can get the vertex. So remember, we're going to do the opposite sign of negative 10 and make it positive 10. And we're not going to do the opposite sign of the 1. It's just going to be 1. Because this moves it right 10 and up 1. So I'm trying to like connect this to some of that other parabola stuff we've done. And then we can really, so that's my vertex. My axis of symmetry would just be x equals 10. So I'm going to box all the things that we're asking for. Okay, so that one opened down. We had to kind of deal with the negative a little bit and think about what that does to the other side. Kind of a pain. Now we're going to look and see what happens if we just have like a whole number sitting there in front of the x squared. We can still complete the square and do all the things. Do you guys need this? Are you done with it?
I don't need that.
Okay, just making sure. I'm trying not to go too fast, but sometimes, because I know there's so many steps, I like start talking fast and it gets crazy. Okay, so on this one, it opens up, but there's a 2 in front. Do you remember what that does to the parabola?
Makes it narrower.
Makes it kind of taller and narrower.
Wait, it makes it taller? I thought they were in.
So what it does is every y value will be twice as big. So it's infinite, but it's twice as big. So each individual y value will be twice as big. It's kind of like changing the slope. It's changing the slope to be steeper. So it's like narrower. So what it does is it multiplies everything by 2. So all your y values are twice as high. Yes, it all goes to infinity, but it does it twice as fast. Maybe that's a better way to describe it. Okay, so we're going to do with the 2 the same thing we did with the negative. But first, let's take care of the 53. Let's just get that moved out of the way.
Take them out back and deal with it.
If you take a college math class at some point, you might have somebody who leaves that over here and they just leave plus 53 kind of to the side. I always found that that confused my students. So if I put it over there for a second, it's not getting multiplied by 2. And anyway, it just usually helps. Okay, so this is gone. And if I'm taking a 2 out of both of those terms, I'm going to have x squared, and then what would my next term be? So I'm taking a 2 out of 2x squared, and I'm taking a 2 out of negative 20.
So 10.
So that'd be minus 10x plus whatever we get to complete the square. So if there's a number there, we're just going to have to divide it out basically, but we're not dividing and getting rid of it. We're just factoring and setting it to the side. It's all kinds of stuff we have to shove around so that we can do what we need to do. Okay, so completing the square. We're going to take that negative 10, divide by 2. I feel like we just did negative 10 because we did. And then we're going to square it, and that is positive 25. So in the parentheses, we have positive 25, but it's actually positive 25 times 2. So that's what I'm adding to the other side. So y minus 3 equals 2, and now I can factor this into my little perfect square. So what goes in the parentheses?
X minus 5.
X minus 5. And then last step,
Add the 3 to the other side.
add the 3, add the 3. So y equals 2x minus 5 squared plus 3 is my vertex form. This makes it twice as tall. The minus 5 makes it move right 5. So that means on my vertex, it's going to be positive 5. And the plus 3 makes it move up 3. So 3. And then axis of symmetry is x equals 5. So once you get the vertex form, everything else is good. I have seen problems on SATs where they give you that final equation and they ask you where the vertex is or where the minimum of the parabola is. And if you know how everything's moving and how this works, that's like a 30-second question. You can click on it and move on. But it does require remembering things. So I haven't seen as many where they're going to make you do this many steps because that would take forever and you don't have time. But I have seen questions where they have it in vertex form, and you have to figure out things about the graph. But also remember, you always have Desmos in your graphing calculator too. So for what you guys are doing, they're not going to have some of that crazy sideways stuff. So thinking about SAT in the spring, you would have your calculator to do everything if you needed it. Okay, so let's do, I thought about making this a practice, but I want to have one more on my video. So let's do this one, but you guys can help me talk through it, and then I'll have you practice on your own on the worksheet.
Subtract 108.
So subtract 106. That's okay. I write down the wrong numbers all the time. I don't know what that is. So y minus 106 equals, and then we're going to take a 3 out. So what's going to be in my parentheses?
It's going to be x minus 36 plus blank.
Okay, so 36 divided by 3, so it's going to be minus 12x. So I got to remember, I'm dividing those by 3 before I put the plus blank. So that is a step that gets missed a lot. Okay, then we're going to take the negative 12, divide by 2 to get negative 6. Negative 6 squared is 36, but I'm not adding 36, I'm adding 36 times 3, which would be 90 plus 18, 108, I think. Correct me if that's wrong, because I was mental math. I'm not super confident.
That makes sense.
Okay. And then this is going to become x minus 6 squared. And then we want it back to y equals, so we'll subtract that 2. Y equals 3x minus 6 squared minus 2. Okay. What's my vertex?
It'll be
Positive 6, negative 2. Perfect. What's my axis of symmetry?
6.
Nope, I can't just write down 6. What do I have to write down? I have to write x equals 6 because of Hooy-Vux. And next year, if they're sideways, it'll be y equals, and so it's super important that we have that correct.